Hey, what's up, guys? This is Chung. So this time, 1723. Find the minimum time to finish all jobs. Mm, so you're given like an integer array jobs, where jobs I is the amount of time it takes to complete the ith job, and you're also given like a k workers that you can assign jobs to, and each job should be assigned to exactly one worker, and the working time for a worker is the sum of the time it takes to complete all jobs. And you need to find the minimum possible maximum working time of any assignment. So the maximum working time is like it's for among all the workers, and what's the maximum working time, and then you need to find the minimum possible number of any of the arrangement, right, to get the minimum of the maximum working time. So some examples, right? So if we have like three jobs, right, and then three workers, obviously, each worker will be assigned to one job. That's why the maximum is three. And for example two here, right? I mean we have 11 because here's the best assignment, right? So which means that the working time for worker one is 1 plus 2 plus 8 is which is 11, and this for the second one is also 11. That's why the output is 11. And the constraint is like it's very small. Basically, the jobs is the length. Is the jobs and the workers, they're only within 12. So this one is actually a strong hint, right? So which means that there is no polynomial solution for this problem, right? Otherwise, it would have been like the 10 to the power of 4 or 10 to the power of 5. But for this one, it's 12. Only 12. So 12 means that this one is like a NP complete problem, which means that each of the job, at each of the job, you can assign the job to any of the workers, right? So which means that, that's gonna be the power, 12 to the power of 12, right? Because both the jobs and the k, they're both like uh up to 12. So that's the total time complexity for this one. And so that's why this problem is more like it's all about cutting the branches and how and also how to do the pruning, because the main logic for this problem is pretty straightforward. It's just like the backtracking, right? Basically, at each of the jobs, uh, we try to assign the job to to each of the workers, and then in the end we get the minimum of the maximum time. Mm, so let's talk about the strategies of cutting the branches. I think there are like some common strategy to cut the branch. I think for at least for this problem, I think one of the ways to cutting the branch is that, let's say we have some workers, right? At one state, we have some workers that uh, have the same numbers, same currently have the same working time, the working time. Let's say we have worker one, worker two, worker three, and worker four. Let's say all of them have the time 10. So for at so for this case, we can we can just try to assign the job to any of them. We don't have to try all of them because each of the workers they're all identical. So that's the first way to cut the branch, which means that if there's like the multiple workers have the same working time, we just need to try one of them. So that's the first one. And the second one, so what's the second way to cut the branches here? And it's that, since we're trying to get the minimum possible maximum answers, right? So which means that we're gonna have like a uh, global variables that to keep track of the current best, the current minimum answer, right? And if the current branch, the total, if the current branch, the total working, the maximum working number, sorry, the maximum working time is greater than than this answer, then we don't need to continue. We can simply stop there, because if we continue, the maximum working time will only become bigger and bigger, since we're getting since we're getting the maximum out of all the workers, and each worker's time can only be increasing, not decreasing. Yeah, and that's basically two strategy to cut the branch for this problem. And yeah, so let's start the coding here. So first, we have a backtrack, right? So that's the basic idea here. So, and we're gonna have like the indices, and then I'm gonna have like um, current time. So this one actually is the current biggest time, right? Current maximum time, max time. Yeah. And then that's that. And we have like a n. Let's define some like global variables, right? And then we have a workers, right? So the workers, the length at the beginning, they're all 0, right? And then we have a k here. So this one's going to be the global variables. And then we have the answer. It's the system dot max, starting with system max size. And then we have backtrack. The backtrack, we start from the 0 index, and then start with the 0 max time, and then in the end we return the answer. Okay, so um, the uh, the exit condition is like this. So the first one is if the I is equal to n, right? So which means that, okay, we have find an arrangement, right? And for this one, we just need to update the final answer, which is going to be the minimum of the answer of the what current max time, right? And then we just need to return. And so I'll try to finish the backtracking part. So and then we can start adding the pruning or the branch cutting logic. So we have a range of k, right? So since we have a case workers, and the so wj jobs I, right? And then we have like the backtrack of I plus 1, and then we have like the max of current of wj, right? Then we have wj, we have the backtrack, yeah, and then and here, yeah, I think that's it, right? I mean, and that's the basic backtracking logic here. And so let's try to add the first branch cutting logic, which is the if there's any jobs, or I'm sorry, if there's any workers that have the same uh, working times, we simply skip that. So I think one way of doing this, I just introduce a time set here, right? So here, and I simply do this, right? Basically, if the current worker J is not in the time set, and then I just do the following. Otherwise, I just skip, because we have seen this time before. And then in the end, I simply add the time set dot add wj. Okay, So that's the first pruning, and the second one is the oh, so here I need to define a non-local answer. So the second one is this, right? So if the current one has reached is greater or equal than the answer, right? And then we can simply return the answer. Yeah, because here basically, like I said, if the not current, if the current max, sorry, has is bigger, right, than best, the minimum, right, then no need to continue. Yeah. So I think that's it. So let me try to run the code. Okay. Yeah. Current max time. Yeah. Okay. Yeah. Cool. So yeah, I mean that's it for this problem. You know, I mean the basic logic for this one is very straightforward. It's just like simple backtracking. And actually for this problem, you know, I was trying to use the greedy method. Like maybe I was trying to use it like a priority queue, try to and then sort these jobs from the biggest to the smallest, and then I was trying to see if I can use the like some greedy approach, solve it. Even though I saw this one, but I was like hoping that if that the greedy works, right? But obviously that one for some test cases it gave me give me the wrong answer. So and then I had to go back to the very basic backtracking, which is the NP uh, complete solutions here, right? And then the next thing is that how can we cut the branch, right? So, I mean, this one, you know, I mean, this like technique is pretty common for many of the backtracking method, you know, because if there are like a multiple like candidates that have this exactly the same conditions, right? And then we can just skip the we can only try one of them. So that's the first one. And the second one is somehow you have to be realize that, right? So this one needs a little bit of observation and thinking, um, because you know once you have like have already accumulated big enough current max time, there's really no need to continue if we have already have like a better answer than the current one, right? Since we're getting the minimum. And yeah, I think that's the two uh, technique to cut the branch for this problem. And yeah, I think that's all about it. Thank you for watching the video, guys. Stay tuned. See you guys soon. Bye bye.